Steam enters an adiabatic turbine operating at steady state with an enthalpy of 3251 kilojoules per kg and leaves as a saturated mixture at 15 kilopascal with quality dryness fraction 0.9. The enthalpies of the saturated liquid and vapor at 15 kilopascal are HF is equal to 225.94 kilojoules per kg and Hg is equal to 2598.3 kilojoules per kg respectively. The mass flow rate of steam is 10 kg per second. Kinetic and potential energy changes are negligible. The power output of the turbine in megawatts is, options are option A 6.5, option B 8.9, option C 9.1, option D 27.0. Now the solution is, steam is entering into a turbine and leaves as a saturated mixture, that is vapor plus liquid. In the problem they have given data as the enthalpy of the steam which is entering at stage 1 H1 is equal to 3250.0 kilojoules per kg, and the steam is leaving at the other end, that is at stage 2, in the form of vapor and liquid at a pressure P2 is equal to 15 kilopascal and the dryness fraction X is equal to 0.9. Mass flow rate M is equal to 10 kg per second. Now enthalpy of the saturated liquid HF is equal to 225.94 kilojoules per kg and enthalpy of saturated vapor Hg is equal to 2598. In the problem they have asked to find the power output of the turbine. We know power output P is equal to M into H1 minus H2, where H2 is the enthalpy of the saturated mixture. So now we have to find H2, but we know the enthalpy of the saturated mixture H2 is equal to HF plus X into Hg minus HF, where Hg is the enthalpy of the saturated vapor and HF is the enthalpy of the saturated liquid. So which is equal to 225.94 plus 0.9 into 2598.3 minus 225.94, which is equal to 225.94 plus 2135.124, that is 2361.064 kilojoules per kg. So now power P is equal to M into H1 minus H2, that is 10 into 3251.0 minus 2361.064, which is 8899.36 kilowatts, that is equal to 8.9 megawatts. So the correct option is option B 8.9 megawatts.